So today we will start with collections. So collections are the containers used to store group of objects. So there are different types of collections available for storing the elements in a sequence, for storing non-duplicate elements, for storing key value pairs. So there are many collection implementations available in Java. So using these collections you can reduce the programming effort because the code that you need to be written is already implemented in the library classes. So these implements a kind of data structures for storing elements in sequence and in key value pairs. So these library classes are improved with efficient algorithms, so the speed and quality of the programs will get increased. So we can use arrays also for storing a group of objects, but the array size, once you specify the size of the array size is fixed. It cannot grow as the elements are growing. So the collections will grow in size as the elements we wanted to store are getting increased. So how much size to increase is specified by a load factor. So while creating an instance of a collection, so you can specify the load factor. So when the collection size reaches to the maximum size, then the size of the collection will get increased by the load factor. So while creating the collection object, you can specify the initial capacity. So what is the initial capacity of storage that you wanted to create the collection, and you can specify the load factor. After the initial capacity is reached, what is the next size needs to be increased using load factor. So the collection interface is the super interface for all the collections. It provides the methods like add, remove, contains. So all the collections needs to implement these methods. So add for adding elements, remove, contains for checking whether the elements is available in the collection or not. Iterator is used for iterating over collection. So in collection you are storing so many elements. So to iterate over collection, so you can use the iterator. So toArray method can be used for getting the array from the collection. So this is the hierarchy of collections. So the collection interface has multiple sub-interfaces, but we commonly used are list and set. So list and set interface are implemented by the classes array list and linked list. Similarly, set has subclass hash set and interface sorted set. It has the implementation called tree set. So tree set will store the elements in a sorted order. So if you wanted to access the elements that are stored in a sorted order, so we will go with tree set. Similarly, we have another parallel interface. So collections are used to store the elements, group of elements, but maps are used to store the elements using keys. So maps will contain the key value pairs. So for this key, what is the value stored? So while storing values, you will specify the key. So the elements can be accessed through keys. So the hash map is the implementation of the map. So sorted map, tree map is the implementation of the sorted map. So similarly in the tree map, the elements and the keys are stored in the accessed in the sequence order. So when you access the keys, so it will return you the keys in a sequence order. So there are different types of collections as we see in lists and sets. So lists are used to store the ordered collection of elements. So it will store the elements in the order that you have stored. So it will similarly it will return you the elements in the order of the insertion. So it will store the elements by index. So that you can access the elements faster by index. So it will allow duplicates elements to be stored. So list interface has an additional methods over the collection. So it list interface extends the collection and it has an additional methods like list iterator, add with indexes. So normal collection will not have the behavior to add the elements with index. You can just add the element, but list interface you can add the elements with index also. So the list implementation classes vector, array list and linked list. Vectors class are synchronized. We will see what is synchronized later. Array list and linked list are not synchronized. So linked lists are faster for insert and delete and they are not optimized for the faster access. So vector and array list are optimized for faster access and random access. So we can define the list to store set of names. So you can use any of the implementation like array list. So list is from the different package. So you need to import that package. So java.util.list. Similarly, array list is from java.util.arraylist. So if you see the constructor of the list, here you can say the initial capacity. So like this you can add as many elements as you can. So you can access the list methods size. So using the index you can access the elements. So the element John is stored at index 0, or you can use the iterator to iterate over the elements in the array. So iterator is used for iterating over the collection. So we are storing the elements of type string in the list. So iterator has the properties like has next element. So you can see the next. Similarly, there is a list iterator for the list. So it has additional methods in the list iterator. This is specially for the list iterator. So it has next and has previous. So if it is so like this, we can iterate over the list of elements, or you can, the size with size method, you can access the elements by index. So you can add the elements in the list with index also. So now I will execute this program. It is an array index out of bounds exception of size 3. So the index should be 0, 1 and 2. So it has printed the element at the index 2 and the size of the list is 3. So using iterator we have printed all the elements in the list. So like this you can use the list collection. So like list we have the set is another collection. So it is used to store non-duplicate elements. It will not allow the duplicates. So elements are compared using the equals method. So equals method is available at object class. So it does not add any methods other than the collection interface methods. So the list interface has added the methods with index, but set will not have the any other external methods from the collection interface. The set implementations are hash set and tree set. Tree set provides the elements in a sorted order. So the order can be defined by the comparable or comparator interfaces. So we will see what is comparable and comparator later. Well, tree set provides the elements in a sorted order. So it implements the sorted set interface. So we will see the example of sort set. So this is the same class that we have discussed in the list. So it has set, we have added the elements. So we cannot add elements with index in the set and we cannot access the elements with index. So we have to access the elements only through iterator. So the size of the set is 2 and the elements can be accessed through iterator. So you can verify the contains method to see whether an element is there in the set or not. So because the element is there, it has printed true. So as we discussed, sets will not allow the duplicate elements. We will try to add the duplicate element. Even though we added 3, so it is say the size is 2 because the Jan is already existed, so it did not add Jan to it, to the set. So maps are used to store the key value pair elements. So the objects are stored based on key. So map implementations are hash map, weak hash map and tree map. So hash map is most commonly used and the default. Weak hash map will be used in case if you wanted to remove the keys if the object is no longer used. Tree map provides the elements in sorted order similar to tree set. So it will return you the keys in a sorted order so that you can access the elements in a map in a sorted order. So if you wanted to access the elements in the sequential order that was implemented, that was inserted, so there is another map implementation that is linked hash map. So this, whenever objects you wanted to access in an order, sorted order. So the objects has to be implement either comparable interface, or you need to provide a comparator to compare the objects or elements that are stored in a collection or map. So comparable and comparator we will see. So we have created a person, two person objects, and we are storing these objects in the map with the key as name and value as the person object. Now how can I access these objects? So you can, if you know the name, you can directly access with the get. For the get you can pass the key. So if I pass John as key, I can get the person object. So I can print the age of a John. So here person.map.get returns as the person object. So person object has the attribute age. So we are able to print the age of a person John. Normally these kind of maps are used to cache objects based on keys. So John age is 32 is printed. So like this you can similarly you can use iterator to iterate over the hash map. So there is no iterator. You have the key set. It will return you the set of keys that will have the iterator. So you can use this iterator to return the keys, and based on keys you can access the map elements. So like this with the iterator you can get the keys. So based on keys you can get the objects from the map and you can access the elements in the object. So we have inserted the objects in the order. First we have inserted John and next we have inserted Bob, but while accessing through iterator, first we got Bob and Young. So the order is not guaranteed in case of a hash map. So if you wanted to get it in the inserted order, so you can use the linked hash map implementation. So which will guarantee you the order of insertion.